Okay, so this video is going to be talking about absolute value functions. And how I'm going to describe this is in a real life situation. Let's say you were on a boating trip and you fell into the ocean and then your boat ended up going away. Right? They didn't care about you or something. And this is you in the ocean. So you either have to swim or you need to be saved. I'm going to reference you as the origin point of a graph. Okay? You can either swim in this direction, or you can have somebody like a helicopter come care flight you out, and you're going to be lifted out of the ocean. Both of these directions are positive directions. Okay? If you didn't have these options, or if you didn't choose these options, you could either swim this direction, or you could actually swim down into the ocean. Now, I don't know why you would do that, but you could. Both of these are actually negative directions. So you can have a positive and a negative direction. What you can't have, though, is a negative distance, and that's where the absolute value comes in. Okay? Absolute value is talking about the distance that you travel. Okay? And it's represented by this function, this parent function. I'll put PF for parent function. F of x is equal to the absolute value of x, and it's represented by by these two vertical bars here. Okay? And so if you were to travel in a positive direction, let's say you traveled, 1 mile, then you'd have like f of 1 mile is the absolute value of 1. This is not f times 1, this is f of 1. So is a positive direction of 1, and if you took the distance you traveled, it would be 1 mile. And so if it's positive inside these bars, then it's still going to be positive coming out. All right? Let's say you were to travel f of negative 1, which means the negative direction of 1 mile. So maybe you went to the left instead of to the right. Well, your distance would be the absolute value of negative 1, which is positive 1, or you traveled 1 mile in the negative direction. Okay? Okay, let's do some more complicated calculations. So let's say we have f of x is equal to the absolute value of x minus 3. Okay? If we end up doing this, we're going to get, let's say we just make up some numbers for x. So let's say when x is, I'm going to say we'll have x, our process, which is x, the absolute value of x minus 3, and then f of x, our output, okay, or what we're trying to solve for. So let's say we have x is equal to 0. I'm just making these values up. Then I would want to plug it in, and you'd get then the absolute value of 0 minus 3. Well, in order to work this, you want to actually take this difference here first, and then take the absolute value. So this would be then the absolute value of negative 3, which is then 3. Okay, so my f of x would then be 3. And I would have, if I were going to plot this, I would have a coordinate point at 0, 3. And that would be my coordinate point. Okay? Let's try a different one. If I had x was 3, then I would have the absolute value of 3 minus 3. 3 minus 3 is 0. And the absolute value 0 is 0. And you'd have if you want to graph that point, you'd have a point at 3, 0. Okay? Let's change up the function just a bit. Let's say I multiply it by 2. So I got 2 times the absolute value of x minus 3. Then let's make up some numbers. Dang it.